Good afternoon, evening. Hello, everyone. Whenever you're watching this, welcome to our monthly Minnesota Night Skies Live. Uh, oh, hello, everyone. If my beginning intro was cut off there, welcome to our monthly Minnesota Night Skies Live. My name is Thaddeus. I'm here at the Bell Museum. I'm our planetarium educator, and I'm very excited to take you on a tour of our What's Up in Our Sky for February. February, of course, middle of the month is Valentine's Day. So for the month of February, I'm actually focusing on just some of my favorite deep sky objects and constellations to see up there. So things we'll be able to see for a few weeks here, good viewing throughout the month, as well as some things just to pay attention to throughout the course of, the next 10 years, actually. What in particular are you going to pay attention to for the next 10 years? Well, let me jump right into one of the greatest things happening over the last 2 months, or a month now, the launch and successful deployment of the James Webb Space Telescope. If you have been invested in astronomy at all, I'm sure you have been keeping up. You've heard about James Webb. If you haven't, James Webb is our latest and greatest space telescope. It launched back on December 25th. And over the last month, it has made its way 1 million miles away from the Earth to, as of yesterday, successfully entering orbit at Lagrange point 2, a somewhat stationary point beyond the orbit of the Moon. And this telescope is about the size of a tennis court. It has a mirror about 20 feet across, and it will capture light from the very beginning of the universe. So very low-level infrared light coming to us from over 13 billion years ago. You can see here the website on the screen was the tracker for it. Where is Webb from NASA, showing the last major thing going on, which was its insertion burn into L2. Over the next 3 months, James Webb scientists will be aligning the mirrors on James Webb. It is 18 individual mirrors that it will align to capture this light. And in approximately 5 months, so right midsummer, we will hopefully be getting the first images from James Webb. I say hopefully, and I think it's all gone great so far. In fact, the launch and deployment of James Webb has been, as I heard it really described, it's been boring. It has gone perfectly well. Everything has worked great. It's been fantastic. 10 years of building and testing, another decade before that of design. That's what it gets you. It gets you an amazing telescope that works on the first go, which is really great. So keep your eye on the news for James Webb, just to see what it's up to, and especially as we reach into summer, keep your eyes and ears peeled for that. All right, but I have jumped us to our sky here in February, because that is what we are going to be exploring a little bit more of. For those who've tuned in before, you may know that I love to start off with one of the brightest things that we can see in the sky, and that would be the International Space Station. Now, there are a lot of ways to track down where the ISS is going to appear in the sky above you. Today, I'm showing you the program Stellarium. It's a great astronomy visualization program. It can show you the sky from anywhere and any when, really. And in particular, it's set up here for February 4th, about almost 6. Well, actually, we need to go backwards in time a little bit. A little past 6:15 here on the evening of the 4th. And as we go forward a little bit faster in time, let's speed up Stellarium a bit here. We're looking west-northwest, and a bright light has appeared in the sky. And that bright dot right here is the International Space Station, passing by the constellation of Pegasus, popping up in the background. If you'd like to see other ways to track the ISS and where it is, we'll put a link into the Facebook chat there, where you can track down where it'll be above your heads. Now, also using that chat today for anyone tuning in, and anyone listening to this in the future, also using that chat for any questions you might have. I'm going to go along and talk about things I really like in the sky. If you have any questions that come up as you're watching this live, or if you're watching in the future, please feel free to put in any questions there. I'd love to answer them. And yeah. Oh, and I want to mention here, the February 4th ISS pass over our heads is a great one. It's going to last for about 6 minutes. which is a nice length of time here, going from west-northwest to the southeast. So pretty high and straight above our heads there. That night as well, on the evening of February 4th, is also our next virtual star party. So you can tune in about 45 minutes after the ISS passes overhead. We'll be setting up our telescopes on our deck and live streaming views through our cameras, showing you what's in the night sky with a live view. We'll also have some presentations from two students here at the University of Minnesota. We have one of our PhD students who studies Mars, and one of our undergrad students who's done some work on Venus and geology. And they'll be talking about giving some short talks about their research. Well, I also talk about some other things as well, the future of spaceflight, basically. So February 4th, that's the first thing. I guess the second thing after James Webb. That's the second thing to keep your eye on for February. All right, now looking at our sky here, Stellarium is great. It shows us pretty much anything and everything we could ever want to see. So we are going to start, but just to narrow it down a little bit, let's start with some of those other bright objects we can see in the sky. Those would be our planets. Now, for the evening sky in February, we've got really one planet that we can easily see for the first week or so, and that would be this one right down here, this guy right down here. To the west-southwest, we have Jupiter. Now, an incredibly bright planet, the second brightest planet we can see from Earth, very easy to spot, somewhat close to the horizon, of course. So if you've got trees and buildings in the way, you might need to find an empty gap there to look through them. But Jupiter is easy to spot and great to see. This planet does have a lot going for it as well. It is, as the largest planet, it is a little bit easier to see with binoculars and a telescope than almost any of the other planets. It's also got 4 bright moons going around it. We see them marked out here: Europa, Io, Ganymede, and Callisto. These are 4 of the largest moons in the solar system. Ganymede actually is the largest moon in the solar system. And they're very easy to spot around Jupiter if you have a good pair of binoculars, something like 15 by 70s, I think, is about a good size for that. So you do need to capture a bit of light. Small telescopes a few inches across, bring them out very easily. And then you have Jupiter itself, best seen, I do think, with a telescope, but those bands and stripes we can see here in Stellarium, those come into view. Those are areas where the gas is rising and falling in the atmosphere, and different elements, molecules are being stirred up in this hydrogen and helium and methane rich atmosphere. So it gives us some very distinctive colors there to see. It's a beautiful sight. We may or may not get to see this the evening of our star party. Again, it does set pretty quickly here. So as we go forward in time, I think it might just be a little too close to the horizon once we start our star party. We'll try to get some images of it, though, before that on that evening to, well, hopefully share with you all as well. It is worth mentioning, I do think as well here, that our star party, and of course, any viewing of the sky that you do, is always weather dependent. So we're going to bring you whatever views we can on the evening of the 4th, if it's not snowing on us, and if it's not negative 10 degrees, because we do have human operators up on our deck operating our telescopes, and they don't do so well in those temperatures. Along with Jupiter, we have 2 other planets in our evening sky. These, though, both of these planets you will need a telescope to see. The first one popping up here is the furthest planet, the last planet in our solar system. That would be Neptune. A telescope to see this one, you need a telescope I'd start with one about 6 inches across. I've seen it well through an 8-inch telescope under very dark skies. It shows up as this nice dark blue ball in the sky. It will appear different from the stars you might see around it. Any stars want to pop up? They don't right now. The stars will be twinkling bits of light there in the sky. Neptune, the planets, any planet will be a nice solid ball or solid point of light that you can see. Now, you can see here in Stellarium, at least, that we also have a beautiful set of rings going around the planet. I would not expect to see that through any sort of telescope. You'd need actually something like the Hubble, really, to spot those rings of Neptune. You might, if you spend enough time with Neptune, get under very dark skies. If you're a really dedicated observer, you might spot its largest moon, Triton, up over there as a very bright point of light. Another large moon in our solar system, another very icy moon, a moon that might possibly have some sort of liquid underneath its surface, maybe very slushy, semi-frozen water, possibly, and might also possibly be a captured Kuiper Belt object. So not originally a moon of Neptune, but a moon that was pulled into Neptune's orbit and originally from much further away. Scientists are still working on that. Neptune has not been super well studied, especially compared to other planets like Jupiter. This is also true for the other planet we can see in the sky on the evening throughout much of February, which would be the planet Uranus. All right, so the seventh planet, and of course, the funniest planet, Uranus is another pale blue ball in the sky if you have a telescope to see it. Technically, it can be seen with the naked eye. You do need very, very dark skies, though, to do that. And those are harder and harder to come by, especially if you're observing from right here inside, the city, if you're right here in St. Paul or Minneapolis. If you get a chance to travel around the world, far up into Canada, far up into the boundary waters, even, you might try spotting Neptune there in the sky. It will be a tiny point of light. It'll be difficult to see, don't get me wrong here. And it might be lost in the glow of the background stars. Again, like Neptune, though, if you have a telescope, you might spot some of its moons. William Herschel, who discovered Uranus 250-ish years ago, found two of its moons that we can see here, Titania down on the lower left, Oberon over here on the about 3 o'clock there on the right. You may notice the names of these moons too. William Herschel was an English astronomer, and although his name for Uranus didn't stick, astronomers did stick with naming the planets after, or the moons of Uranus after the English playwright Shakespeare. So naming after his characters from, you can see Miranda and Ariel, Puck up there, Midsummer's Night Dream fans, Cordelia and Desdemona. Okay, you can look up those. You can track all those down later. Coming back again to our sky here, what else is up there? Well, quite a bit. Where to start? Well, you know what? Let's start, in fact, with, again, with some of my favorite objects here. The first one I think is actually many people's favorite. Looking here to the southeast, we have 3 bright stars right in a row, almost vertical, kind of a tilt there above the horizon. These 3 stars making up the belt of Orion the Hunter. So Orion here, one of the most famous constellations across the world, very easy to recognize, very easy even to imagine as a person as we see him there in the sky with his arm or club stretched above him, his shield. We see a pelt of an animal here. In mythology, you might know that story. We see his, what's also sometimes depicted as his bow as well. It might be pulling back an arrow. Orion, one of my favorite constellations and many people's as well, containing also one of my very absolute favorite deep sky objects out here. Looking below the belt of Orion, those 3 stars, if you come down from it, there's a little string of stars, the sword of Orion hanging off his belt. And that's where we find M42, Messier 42, the Great Orion Nebula. If you've talked to any astronomer at all, especially any amateur astronomer, anyone who goes out observing, you've probably heard about M42. If this is your first introduction to it, it is a beautiful sight in the sky. It is a massive, beautiful stellar nursery. So that bright glow we see there at the very center is where the trapezium cluster, a collection of about a dozen bright young stars, are forming, and all throughout this entire nebula as well. There are hundreds, thousands of new stars being born as we speak, putting out light, heating up the gas and dust around them, putting out more light for us to see. Just making it absolutely astonishing. And something you can see with the naked eye. So if you have those dark skies, again, you're maybe going camping out, still winter camping, I guess, in February there. But if you're getting out there away from city lights, you can see it with the unaided eye as a bright smudge there. Binoculars are another beautiful sight. And of course, a telescope brings out M42, the Orion Nebula, just beautifully there in the sky.
Hey, Tad.
Yes.
From the audience is curious if you can show us Titan.
I kind of can. I have to run backwards in time, but I'd love to do that. Titan, if we're thinking about the same thing, is one of the moons of Saturn. And Saturn is not quite in our sky right now. Let's see if we can track it down. It's quite a bit below the horizon. In fact, oh yes, as we go into February, Saturn is right next to the sun. So we're not going to see Saturn in February. because it is right near the sun. And so if you try to look at it like with a telescope, you'll probably end up looking at the sun and you'll burn out your eyes, and that's bad. Don't do that. Luckily here in Stellarium, we can do a few things. We can turn off the atmosphere, which makes it a lot easier to see Saturn. And of course, we can zoom right into it, see its beautiful ring systems, its plethora of moons here, including coming off to the lower right here on the, we're still looking at the 4th, but now here about 4 o'clock, we see the moon Titan. Now, did someone there, did they just want to observe, did they have a question about Titan? Did they just want to see it? It's an amazing moon.
Yeah, they were just curious about what it looked like, if we could see it. So,
Yeah, so I have not seen it with a telescope myself. I've read reports of it, people who have observed it. It can be seen with a telescope, kind of an orangey hue to it. It does have it is orange in a sense. It's what we're seeing here is a view of Titan, and this isn't the atmosphere of this moon. So we're not seeing a solid surface of it like we might see if we're looking at something like Mars. But we're seeing more like we see with Saturn and Jupiter. We're seeing the atmosphere. Now, Titan does have a solid surface below it. It's a frozen surface. It's about negative 250 degrees on the surface. So the water that we found there is frozen hard as a rock. And it turns out this atmosphere is then made mostly of methane gas. So it is a sort of a natural gas planet with a methane-rich atmosphere. And that methane absorbs blue light, reflects some red-orange light back to our eyes, giving it this beautiful appearance. It is well worth looking for. It is a moon that, in fact, we maybe, hopefully, are going to, assuming everything continues to work out well. The Dragonfly mission is planned to go to Titan. Named the Dragonfly because there's potential for a sort of quadcopter to be on the lander that lands on this moon, and then we will attempt to fly on Titan. Dragonfly is still in development. I don't believe it will launch for at least a few years now, but keep your eye on the news for that one as well. For some, hopefully in the near future, in the next decade, some incredible new images of Titan. The images we have right now are still incredible as well. If you look up images from the Cassini spacecraft, Cassini, Cassini, was a spacecraft that was around Saturn for 13 years, and it dropped the first lander onto Titan, the furthest place we've ever landed in the solar system, showing us this incredible, incredible landscape that's there, and really giving us some of the information I just shared with you. All right, and thank you for interrupting. So in the background there, that voice you just heard was Emily, one of our marketing folks. She's in the background, keeping an eye on the chat. So if you have, again, any questions, please feel free to pop them into the chat there, and Emily will be able to get them to me to answer. Looking back at our sky and checking my list of what there is to see up here, so much more. And we had Orion here in the sky. I'll bring back Orion there. And we'll go a little bit later in the night, about 8 o'clock here, and looking roughly to the south. There's a lot to see around Orion, very maybe familiar constellations by name. Above Orion, we have Taurus the Bull, battling Orion there in different stories. Down from Orion, we have Canis Major, the larger dog, one of Orion's hunting dogs. Coming up from the bright star in Canis Major, the star Sirius. Coming up from it to the left, upper left here, we have the star Procyon, which makes up the very complicated constellation of Canis Minor, the smaller dog, which, yes, if you're seeing it there on your screen, is in fact just a stick in the sky. It's a lot. You need a bit of imagination for that one. What can I say? Oh, and keeping these up as well. So the hunting dogs of Orion are sometimes depicted as hunting, they're battling Taurus there in the sky, but they're also linked as well to another constellation, another bit of prey that the hunters are going after. That would be right below Orion. Looking below Orion, there is a handful of stars, about half a dozen stars. Can pick out just about in the center of the screen here as I zoom in a bit. If you draw them together, you might see a bit of an hourglass shape in the sky right here. But astronomers in the past saw this as Lepus, or Lepus, the bunny or the hare. The bright star here coming down from, down from Orion's belt, essentially. This star here, Arnab, is the brightest star of Lepus. and Nihal as well, right below it, are very easy to see. And bringing up, there's Lepus, but bringing up our deep sky objects here, there are two objects I want to point out nearby Lepus, and they're both sort of on either side of it, one above it and one below it. So the one above it is called the Spirograph Nebula here, and it's a fainter object here. You will need a telescope to see it, but it is a planetary nebula. So this is, in fact, the death of a star. So the Spirograph Nebula represents a star probably very similar to our sun at one point, a few tens of thousands of years ago. It expanded into a red giant, and then the outer layers of the atmosphere kept expanding outwards. As that happened, it left behind this glowing outer shell of material. And although the image here is a little fuzzy, we're going to put a link in the chat to a slightly better resolution image of it. And you will be able to pretty easily see, I think, why they call it the Spirograph Nebula. If you've ever used a spirograph toy, which you can draw out complicated lines and geometrical figures with it, this nebula has that same appearance as what you can draw yourselves. Astronomers are still studying why this nebula has this particular appearance here. It's possible there's something going on with the pulsations from the star, the energy coming out from the star, maybe ebbing and flowing back and forth, and that's building up sort of chaotic. Could almost think of as weather patterns in this atmosphere, but still something that we're studying. So that's the Spirograph Nebula above Lepus. Coming down a little bit below it, we come to one of many globular clusters in the sky. This one, though, M79. Now, anyone who's as well seen our monthly star shows before that I do here, anyone who's ever talked to me about objects knows that I absolutely love deep globular clusters. If you haven't heard that before, well, I love globular clusters. They have, at first glance, a lot of similarities. Globular clusters, like we see here on the screen in front of us, are collections of tens of thousands, hundreds of thousands of stars, incredibly old, on the order of 11 to 12 billion years old. M79 here, in fact, is about 11.5 billion years old. Globular clusters also orbit very far away from us. This globular here is 40,000 light years away from the Earth. So orbiting well outside the Milky Way galaxy, but still part of the Milky Way itself. In fact, it's bound to the gravitational pull of the Milky Way. It's orbiting around it over hundreds of millions of years. Now, those are all things that globulars have in common, but they also do have their own differences. A slight difference in age means that we have we have stars in slightly different ages of their lives. Some globulars might have more reddish stars, and that in fact is the case with M79 here. Other ones we've seen have younger, bluer stars, which are kind of odd, but astronomers have determined that these young stars that appear in globular clusters come about when sets of stars merge together, adding hydrogen fuel to their cores, allowing them to burn brighter, giving them the appearance of being young, in fact. Not actually young, but made from very old stars. So M79 is one of these globulars. There's going to be at least one more I'll point out in our time here today. But we are going to jump around a bit to, back to Canis Major here. So one of the dogs hunting Lepus the bunny. And we're going to go a little bit later in the month, just so Canis Major is a little bit higher. We'll go mid-month, or I guess we'll go, to Valentine's Day there, because I'm talking about objects I love. And coming and looking at the back of Canis Major here, we see the dog in the sky. And right on the tail of the dog, the hind legs, we've got a few stars here whose names I will not try to pronounce because I inevitably say it horribly wrong. Coming off the top of the tail of the dog, sort of coming, in fact, off the butt of the dog here, right above the butt of the dog, we find several objects, in particular, the Tau Canis Majoris cluster. The Tau Canis Majoris cluster is, in the grand scheme of things, maybe not anything special. It's a young cluster of stars. It's less than 5 million years old, somewhere between 4 and 5 million years old, which is pretty typical for an open cluster of stars. There's a lot of bright young blue stars. We've got some older, they're going to be cooler red stars, still around the same age. There's several hundred members of this cluster. These are all very standard things, just like globular clusters have things in common. The Tau Canis Majoris cluster, though, I think is just simply one of the more beautiful ones to look at. It's dominated by this very bright, very, very bright central star, Tau Canis Majoris, the star itself, which gives the cluster its name. And it leaves a sort of gap around it. So as you look at it through a small telescope, you'll see the bright star, and then you won't see that much. There'll be this empty area because the light of that star is just blocking out all the stuff around it. But then coming out from this, there's these shells of stars that appear to your eyes as you continue to look. So it has this beautiful concentric shape going out from the center there, just making it really beautiful to look at. And as well, I should say here, very easy to find, which is always one of my criteria as well for looking at objects in the sky. Coming right off the back of the dog, you can find Tau Canis Majoris and the cluster surrounding it. As well, we're going to actually put another link in the chat. There are some really great images of this. In particular, I want to call out one from Spitzer, the Spitzer spacecraft, which is no longer operational, but Spitzer took a really great view of this area surrounding it, showing us as well the nebula nearby it that's probably associated with it, probably part of the nebula that that may have helped birth these stars that we now see there. So we'll put that link in the chat there, Emily, as well. Thank you for doing that, getting that in the chat there for me. It's worth pointing out as I go along, as I point out my favorite objects here, as you can see from Stellarium, all these names and dots that have popped up, these are what Stellarium are showing for fairly bright objects in the sky, just in this one part of the sky. So there is a lot more to see up there. If you want to track down your own favorite objects, Stellarium is a great way to do it. One of my absolute favorite programs when I'm not just using our full planetarium software to show the sky. All right, looking here though, we've been spending time looking to the south. We're actually gonna flip around a bit and I'm gonna move us around. We look to the north. Now, if you're actually trying to track down your directions in the sky, looking to the north is probably one of the first things you'll try to do. And in particular, I am sure that you'll probably try to look for the Big Dipper, which we see over here to the northeast, standing almost straight up and down. The Big Dipper here is part of the larger constellation of Ursa Major, or the larger bear. Now, the Big Dipper is always in a different place in the sky, but we can always see it. And the two stars at the end of the bear, or it seems the end of the bucket of the Dipper, Dubhe and Merak, these two stars here, Merak on the bottom, coming up through Dubhe, they point us over here to Polaris. Polaris, the end of the Little Dipper, or Ursa Major, or excuse me, Ursa Minor, the smaller bear, cute little constellation. Polaris is not a very bright star, but it is a very notable one because it is our North Star. So as the night goes along and all these stars move around us in the sky, or at least they appear to move as the Earth spins around, Polaris will stay in one place. So it'll always be right there to the north. We go really fast here, we can see that motion, and then we'll come all the way back around again to see Polaris staying still. All right, yeah, we paused here, great. And we're back a little bit later. We'll go back, in fact, to, that's fine, back to 2000 hours, 8 o'clock. Polaris then is our North Star. If you can find it, if you're facing north, you can track down all your other cardinal directions that way. All right, but going back to Ursa Major, the next object I want to show y'all is right above the head of Ursa Major. So if you can find the bear here in the sky, and if you can imagine a bear there in the sky, we've got his eyes up front, depending on how you look at it, one eye there. We've got sort of the neck back over here. And coming up off the back of the neck of the big bear, we can find Bose Galaxy right around here. A companion galaxy would be Cigar Galaxy. These two galaxies are known as M81 and M82 as well, if you're looking them up. But the Bode Galaxy and Cigar Galaxy are common names for them. These are, well, I'll focus on Bodes for a second here, because this is the one I prefer to look for first, at least in the sky. Cigar Galaxy is great as well. Bose Galaxy, though, is just a fantastic one to look for. It's very bright, first of all, so easier to find. And as galaxies go, that is worth a lot. Galaxies are faint objects in the sky, so you do need a telescope generally to see it, although I've heard some people say they can see this one but not with binoculars. It is bright because it is in many ways similar to our Milky Way galaxy. It's about 100,000 light years across. It probably has on the order of a few tens of billions, hundreds of billions of stars. And it is this beautiful spiral galaxy. So looking at, this is an image from the Hubble Space Telescope, but looking at it, we can see these spiral arms wrapping around a bright central core there. So looking through a telescope, you can actually pick some of this out. You might first see it, at least speaking from personal experience, you might see it as a sort of bright, elongated oval there in the sky, sort of this fuzzy oval shape. Looking at bigger and bigger telescopes, you get into 10, 12-inch telescopes, very large Dobsonian type telescopes. You might pick out a faint spiral structure to those arms as well, with again, that bright core there. All this detail as well means that it's a great object for anyone getting into astrophotography. So if you like taking images of the night sky, Bose Galaxy is a great place to start. As well as companion over here, I will not forget the Cigar Galaxy M82. This galaxy here is literally a close companion to M81. They're separated by a few tens of thousands of light years. These galaxies are in the process of interacting. So they're in fact brushing past each other. They may, over billions of years, come back together and merge into a new galaxy. That remains to be seen. At the very least for right now, as we look at it, we see the influence of gravity. We see a huge amount of stars being born as gravitational push and pull of the galaxies stirs up gas and dust. And in particular, we can see that in these red plumes coming out of the galaxy. These are areas where hydrogen gas is being ejected from the center, especially from the very center where there's a supermassive black hole. But it's the combined light of all this activity causing gas to be thrown outwards. And again, making, with millions of new stars being born, making it easy to see.
Hey, Tad, are you ready for another question?
Always, definitely.
Awesome. So someone from the audience is wondering, the first star James Webb Space Telescope will calibrate is either the HD 84406 or TYC 4139 9711. Maybe you could show us where those are.
Sure. Well, let's see if Stellarium has them. Let's read off the first number again, because I didn't quite catch all of it, but it was HD, correct?
Mm-hmm. HD 84406.
84406.
Mm-hmm.
All right. Well, Stellarium took me here. Let's try that one more time, just make sure I get it right. It's right here. I'm going to change one of my options here in Stellarium, make sure we are not, ooh, yeah, we'll just turn all the stars on here. All right, it looks like if I got it right here. 1 second. It looks like this star right here. This is good. So I have not tracked down these stars here, but it looks like this first one at least, if I've got it right, 84406, the Henry Draper catalog, is also here in Ursa Major. So great, very close by. It will look, if you see it, it looks like it's magnitude 7. So probably won't see it from inside the city. Binoculars though, and darker skies, guarantee you'll see it. Right above the neck of the bear as well. It looks like it's a pretty average star, all things considered. Little bit bluer, if I'm reading that right. Oh, it's a G-type. Yeah, so it's a star actually very similar to our sun. G-type star. What was the second one? It was a TYC catalog, which I never remember the name for.
Yeah, so it's TYC 4139 9711.
Oh, and it looks like that might be the other name for the same Henry Draper star. Cool. So stars have a variety of names depending on a variety of things, who's seen them, who's cataloged them, and what astronomers want to use the name for again. Hipparchus and HD are two very common ones, standing for two different catalogs, two different sky surveys, tracking down, going back now several decades, tracking down bright stars nearby us, making the first giant catalogs of tens of thousands of stars. TYC, I can never remember what TYC stands for, but it would be another sky survey of stars, tracking down stars. All right. Speaking of tracking down stars, looking at our time here, we're going to go just a couple minutes over because I do want to point out one final thing very quickly, which looking for, speaking of fainter objects here, I'll bring up a few more constellations. We've got the Big and Little Bears, going between them, we have Draco the Dragon. Coming over to the northwest, we have Cepheus, and above him, the Queen Cassiopeia here. Looking a little bit over towards the moon, we find the first glimpse of Leo the Lion that we see in February. So if you are, waiting for springtime, February is when we start seeing Leo start to roar up in the sky there. So it's always great to see him come up. Looking higher in the sky, we find Perseus as well as Capella and Auriga. And then coming back around as well down to the east, we find the twins, Gemini. And then, there's Cancer that I clicked on. Now, this sort of ring of constellations that I've pointed out here, these sort of mark out a larger kind of empty area in the sky. If you're really looking, though, if you have dark skies and good eyes, you might be able to find a few other constellations. One over here is called Camilocritus, which is a giraffe, coming from some fun Latin. But then as well, going in this area here in between Gemini and the feet of the bears, coming from Capella in Auriga and the head of Leo the Lion, is where we find the constellation of the Lynx. This is simply one of my favorite constellations because I am a cat person, so I like looking for it. It is made up of very faint stars, though, so you will need the eyes of a cat to pick it out in the sky there. Looking, though, at the Lynx, though, this is where I want to show one final globular cluster, which is the Intergalactic Wanderer. I'm just going to do a quick search for this one to bring it up. There it is over here. It is a fainter globular cluster. You will need a good star chart probably to track it down. It is kind of near the head of the twins, though, and try to keep it in view here. And that can help you bring it into view. Again, a telescope you'll need to use a telescope to see it. But it is a absolutely beautiful globular cluster, like all of them. Its particular fame, though, comes because it is the furthest globular cluster we can see from here on Earth. That is still sort of considered part of our Milky Way galaxy. It's about 300,000 light years away, which is really, any way you look at it, very, very far away. And it's thought to be a captured globular cluster, so thought to be probably part of another galaxy that went by the Milky Way, got torn apart, or is in the process of doing that right now. And this globular is now becoming attached to our Milky Way, so bound by our gravitational pull. At this distance, though, it takes about 3 billion years to make one orbit around the Milky Way. So really determining what it used to be a part of, what it is a part of, the final stages of it, that's going to take, probably 1 billion years more just to track that, gather all that information, narrow it down. But if you have good eyes, good dark skies, it is worth looking for. All right. Then as we do reach to the end of our time today, I want to bring those constellations back up, just bring as many as I can. Oh, and they're disappearing on me instead. Bring them up more because there is a lot more to see in the sky, from the constellations that are there to deep sky objects. And for those as well who are searching for things closer to home, I also want to point out, right back where I was, our moon. As we head towards the full moon in the middle of the month, keep your eyes peeled for information, eyes peeled and ears open for information about the Artemis 1 mission. Artemis 1 is our next return to the moon. It is the next spacecraft that will carry the first man, the next man and the first woman to the moon. And it is set to launch hopefully now in March. However, it did just pass its next great milestone yesterday, literally like 20 hours ago. There was a simulated countdown within the vehicle assembly building, a full countdown in preparation for the wet dress rehearsal coming up, hopefully in a few weeks here. And everything does seem to be on track as of right now. Artemis is going to be a great thing to get us back to the moon and then beyond to Mars, which, if you want to see Mars, head out into the early morning sky in February to track down both Mars and Venus in the early morning. If you want to see our moon, though, you can see it right now being eaten by Leo, which is a fun little view. As we get, though, to, I believe we're a little past the end of our time here. So I want to check Emily and see if any last questions from anyone out there.
We did have one question from the audience about why the bear's tail is so long. Thinking about Ursa.
Yes. So I I'm not sure I have time to tell the entire story today, but it does relate to some of the mischief that the bears were getting up to originally here on Earth. So these two bears that we see do have very long tails, and it's said that they were wreaking havoc down on the Earth. They were trampling over houses and crops and people. And so one of the great heroes, possibly the hero Hercules, somewhere around here in the sky, Hercules grabbed the bears by their tails, swung them around his head, and swung them up into the sky where they now stick for us to see. Stretched out their tails and stuck them in the sky, circling around us forever and ever. There are other stories about that as well. And in fact, the constellations that we see here are not the only groups of stars recognized in the sky. One final thing I'll point out about Stellarium is that it gives you the opportunity to view a variety of different sky cultures. So looking at star lore from groups of people around the world. I've been sticking here with Western ones, but if you would like to go through, in particular for any Minnesotans, especially indigenous Minnesotans, you can explore Ojibwe constellations put together by Dr. Annette Lee and Carl Gabwe, and as well as William Wilson. I think I got William's first name right there, at least Mr. Wilson. Dr. Lee put these together as part of her Native Sky Watchers program, which you can also check out and explore more about how indigenous Minnesotans have seen the sky. And it's worth noting here as we wrap up our time today, especially looking at these different sky cultures, the University of Minnesota and where I am right now at the Bell Museum is actually sitting on Dakota land. So if you choose to identify yourself when you come visit the museum, if you're a member of any indigenous tribe, in fact, not just Dakota, but any member of an indigenous tribe, we do have waived admission for tribal members. Recognition of the fact that we are sitting on the land that you own. And with this last view of a few of the constellations that remain to us from these cultures, I want to thank you all for tuning in today. Thanks for those great questions along the way. I hope you all get a chance to go out and see more of the night sky, track down your own favorite objects, maybe see a few of these as well if they've sparked your interest, and stay safe and stay warm as well out there. Thanks for tuning in.